I'm Sasha Biberman. I am the co-founder and CEO of Jisto, and I am a former postdoc of MIT RLE department. My background is in engineering, so I got my PhD in electrical engineering, looking at optical communication systems, specifically silicon photonic based, and how to apply them to larger scale communication and computation systems. So we were looking at how these systems are going to impact data center performance, specifically on the energy and bandwidth and all the things, and high performance computing systems, supercomputers, things like that. So there's a lot actually to gain from going optical inside of the networks of these systems. You can get orders of magnitude improvement in bandwidth, you can get orders of magnitude reduction in energy and so forth. So there's a lot of reasons for for going optical in these systems. And so I have some experience looking at these large-scale systems, and from my experience personally, I know that they're underutilized. To step back a little bit, there's kind of two ways how companies are underutilizing their resources. One is the one that I mentioned, which is they over-provision beyond a certain amount. They have this amount that they pay for, and they have this amount that they're actually using, and it's typically much lower. Second way companies are over-provisioning their resources is on a research organization, MIT and others, and various companies, we're seeing that companies sometimes they have their private data center that they use, and different research groups have different access to different amount of nodes inside of that cluster. So you have this big pie, you split it up into smaller pieces, and you hand it out to different research groups, right? And typically, you have a research group, I did some, research at MIT, we had a cluster that we used. So I know firsthand experience, it's a very difficult problem from the research group perspective to actually be able to actually use those resources efficiently. So just as an example, I'm in a research group, say I have access to, 5 servers in the cluster. And, I make a deal with my group that, okay, I'll use it today, say today is Monday, tomorrow, like John uses those resources, and Wednesday, somebody else uses them. So say, for example, I don't get to it today, like my schedule's too busy. So what happens is those servers are, the time that I don't use it, are just sitting completely idle. And say tomorrow I hand it over to John, and John only really needs, one server, to do his job. So the rest of the 4 are just sitting completely idle. And say he hands it over to somebody else on Wednesday, and that person actually doesn't need 5, they could really benefit from 10 or 20 or more, but they are really constricted to the 5. So it's like, it's very tough to actually fit into whatever slice of the pie that you're designated. So what Jisto does is it's able to essentially break down these artificial static walls, with this ownership profile, and essentially put in this dynamic environment that allows people to use the idle capacity of the resources. So, if I'm a research group and I have access to my resources, I'm always guaranteed that. So if I ever come on, if I come back on Monday and I start using them, I'll be able to use them. But when I'm not using them, somebody else can use them and run more applications on them. And this way, when I need resources and, instead of just getting the 5, maybe sometimes I get access to 10 or 20 or more when the resources are available. So this way, kind of everybody can share each other's resources without being in the way of each other. And the second way that Jisto helps with the utilization is going back to that problem that I was saying where companies just naturally over-provision. What Jisto does essentially, so there's a gap, how much they pay for, how much they're actually being able to use on average. What Jisto does is essentially can fill that gap temporarily and essentially allow the company to use more of the resources. And if there's some mission critical application that wants to spike, and hypothetically we have no way to predict the spike, or let's say we have no knowledge of the spike, we have an elastic method where we completely back off the resources. So the resources that actually need the priority can still have the priority, so it doesn't add to the risk of those applications.